Perfect. Okay. So it's called a piecewise defined function. Reason why it's called piecewise, you're taking a piece of several, can't spell, sorry, of several functions. So take a look at this graph down below. The first piece off to the left. What does that look like to you, that first piece? What shape does that look like? Linear, like a line. How about the second piece? What does that look more like? Parabola. Now, is this a whole line? No. Is it a whole parabola? No. It's a piece of each. That's what's called a piecewise function. You're taking a piece of several functions. Also, it's a function. So it has to pass what test? You guys remember the name of the test? Good. Yes, vertical line test. Awesome. Has to pass the vertical line test. So if I were to draw vertical lines, and what is that? Well, actually, someone explain to me, what is a vertical line test? What does that mean? How do you pass it? Go back. Yeah, totally. If it touches more than once, it fails. So if I draw all these red lines that are vertical, am I ever touching more than once? No. Now, it did seem like we had a close call on the y-axis, but notice that that's filled in. And that's open. And that is very important, because if that were filled in, then you have 2 points that share the same x value. And that's not okay, right? We can't have that. Remember, to be a function, every x must be unique on the function, right? Or on the graph or whatever. So it has to pass vertical line test too. Very important, because I've seen people draw these piecewise functions in very funky ways that would fail the vertical line test. So you know it's not right. And each part, or each piece has a limited domain. I'll explain what that means just a little bit. But each piece has a limited domain. So in the one above, let's do it. Let's try to come up with the equation for it. Okay, so usually we write like this. So you put like f of x, and you put a little equal sign and a brace there. What do you think would be the equation for this guy? If you had to come up with an equation for the first piece, what would you guys say? It's a line, of course. What's the y-intercept of that line? I like that. It's a negative slope and it has a y-intercept of 0. I like that. Good. So I'm going to put negative x. And then I'm going to put a little if statement here, but I'll finish off the if statement just a little bit. The second piece is a parabola. We know parabolas tend to take on this equation, right? Vertex form. What would you say the vertex is for this parabola? I like that. That's good. Thank you, Jack. X squared plus 1. Yeah, because it has it's shifted up 1, right? 0, 1 looks like the vertex. Yeah. And we have if statement there. Now, here's how you write the if statements. The if statements are absolutely crucial. Y equals negative x. If you look at the whole thing, it's supposed to be like this, right? I got y equals negative x. But do I have the whole line? No. I only have a piece of it. And where does that piece start? Or what x value does it start at? And is it going to the left of 0 or to the right of 0? To the left, totally. And is 0 included? No. So you're going to write this. If x is less than 0. If x is less than 0, we want this equation. No other time. When x is less than 0, I want that equation. How about the parabola? Yes, good. Yes, thank you again over there too. Yes, good. And it does include it, so I have to put equals. It does include it. So I'm going forever to the right. So if I grab the whole thing will look like this. I don't have the whole thing. I would have the right half. Where does the right half start? At 0, included, and you go into the right. So the domain is going to be all real numbers. Because duh, look at it. There's no x value that's excluded. All real numbers is my domain. Plus, look at that too. Right? I'm not leaving out any x values. So that's all real numbers. However, the range is limited. Careful with this one. What do you think the lowest y coordinate is here? 0 included. So you still say 0, but you don't include it. And does it go up forever?
Yep, and there's no gaps between 0 and pause infinity. So you're gonna say that. But you can't go below, but there's nothing below the x-axis, so I don't have that either. Okay, we're cool. Okay, good. That's a piecewise function, guys. That's now why do we have it? Why is it important? I'll explain why. This is all about modeling. Okay, when you're trying to model a real life situation using equations, say for example, you're driving from here to Los Angeles, right? Okay, well, I'll give you a better example. Let's say you're driving up and down Valparaiso, right? So say you're in El Camino and you want to get to Alameda de los Pollos, right? Maybe you're coming from, I don't know, the gas station and you want to get to like maybe Starbucks off Avian, whatever. Those Pollos. On Valparaiso, usually there's not many stops, right? I mean, there's some stops, but how many traffic lights? There's one traffic light by Menlo, and that's pretty much it, right? Yeah. You pretty much just go all the way through. And hopefully you don't speed, but can you go the same speed for the most part? Probably 30 miles is okay, right? Don't go too fast. But let's say you're driving from here to Los Angeles. Are you gonna drive the same speed the whole time? No, sometimes you go a little faster, sometimes you go a little slower, sometimes you stop, sometimes you speed up, whatever. If you want to model that trip, you have to use a piecewise function because you can't use the same line to describe your trip, right? That's why we have piecewise functions, because you can't really use the same equation for the entire situation. Or this case here, right? Apparently, if this phone company charges you $40 for the first 450 minutes, and then 45 cents per minute after that. That's how cell phones used to work about 15, 20 years ago. If you go over your limit, then you paid a lot of money. Now it's just unlimited because we have better data now, but that's how it used to be back in the day. Same thing with text messages too. Anyway, so this is a piecewise defined function with many pieces. Describe each piece in a domain, blah, blah, blah. Then describe the domain, then write an equation. Okay. So describe each piece. So that's kind of open-ended, I'd say. Let's look at this first piece here. What's the domain of that first piece? It goes from what to what? 0 to 450, totally. Yep. Because you may not talk to anybody, but you can also talk up to 450 minutes. And what's the range here? What's the only y value for that line? So you just write y equals 40. That's it. Now let's look at the next piece. What's the domain for that next piece? It goes from what to what? It goes from 450, but not inclusive. I don't know why I included it. I was dumb. Up to 451. And what's the range? Y equals what? About 40.45, I'd say. Okay, sorry, I do know what it is.
What are you? How much extra you charge for everything? So it's 40.45. Not like I looked at it. Oh yeah, I know it's 40.45. I was just working if I eyeballed it.
But you're told that in the problem that's 45 cents more than 40 minutes, so 40.45. We're not going to do the rest of those 4 segments because that just takes a while. But you get the idea, right? Like every piece has its own domain, right? Its own condition, like x is greater than or less than whatever, just like it's on the previous question. And also it has its own beats in terms of what y equals. Y equals 40 for the first one, y equals 40.45 for the next one, be 40.9 for the third one, and so forth, right? Or what would that one after that be? 41.35 and so forth, right? So write now an equation for this. Let's do it. Let's write the equation. So you're going to say f of x equals. Okay, it's not so bad. It might seem like a pain, but it goes by pretty fast. So the first equation is 40. The next equation is 40.45. What's going to be the third line? 40 point what? If you're adding 45 cents every time. 40.90. And then 41.35. 41.80. And lastly, 42.25. I think, yeah. Then you got to write these conditions. If x, sorry, I'll just put if and then a blank. If blank, if blank, if blank, if blank, if blank. Okay. Clearly, the first one is when it's between 0 and 450. And sorry, yeah, 450 was included. The next one's from 450 to 451. And then you just keep trading off, right? The equal signs. It becomes kind of robotic at this point. So there you go. That's the piecewise function. Some people call it a step function too. They'll get steps of the staircase. So people call that too. Also called a step function if each piece is horizontal, which of course it is, you know. So cool. Good. Okay. Let's keep on moving. So for this one, we want to fill out the table and then use the graph table that you made to write the equations for each piece. Okay. I think you guys could handle this. I'm going to have you guys do this in your table groups. And then we'll talk about the challenge at the bottom. And then we'll do a couple more after that. And then we're pretty much done with notes. So in your table groups, let's work on 155. Let me zoom out a tad. I'll write out the answers in just a few minutes. I'll pause my recording and you guys can get started. Okay. So what happened here, guys? We have four equations: y equals -2, y equals -x minus 4, y equals x minus 1 squared minus 5, y equals 4. The parabola, just look at the vertex and just make sure it doesn't stretch. It's just like it's going up one, right one for the first point after the vertex. So that's fine. That's easy. Slope and y-intercept. The condition that you have to be very mindful about. Don't mess those up, please. Because they'll mess up the whole thing. It's going from -4 to -2. The first one, -2, 1, the second one, 1 to 4, the third one, 4 to 7, the last one. So that's why making a table could help in terms of making the equation from the piecewise function. Okay. In terms of transformations, let's hold off on the challenge for now. Because I really just want to introduce a topic to you guys, but just so you know what you would do, in case you're curious, what you do is you'd multiply y by -1. Here, multiply y by half. Guys, let's focus, please. Add 4 to x. Add 4 to y. So that's all you're doing. That's how you would transform it. So you would take the table you made and make those changes based upon those transformations. But we're not going to actually graph those because it just takes a while. I'm not going to make a new table, new graph. That just, yeah, it just takes too long. Actually, hold on. Maybe they do it on the next page. Let's see. What's going on the next page? They do actually do it. You know what? Let's do it. I think we can. Let's do it for maybe A and C. Maybe we don't do it for B and D. Let's do it for A and C. Just so we. So here's our new. Okay, so it's down below. Got it. Okay, so let's do it for A and C. So what did I say we do with the negative f of x? I said we multiply y by -1, right? So the previous, great. I wish I recorded the last one before. So these are the previous ones. What were they again? It was -2, -2, -2. Then what was the next one? -3, -4, -5. Guys, Ellie, Sophia, thanks. That's -4, -1, 4, 4, 4, 4. Okay. So what's going to happen next? If you put a negative out front, how do I change the y values again? Right, so now they all become positive. And those are positive are now negative, right? So 2, 2, 2, 2, then 3, then 4, then 5, And then 4, then -1. No, sorry, it's +1. My bad. +1, then -4. So graph's gonna look kind of like this. There you go. You see how that graph is flipped compared to the original? So actually, I'm glad we should have, yeah. It says channel, but you guys can have it. So that's what's happening. Right? So you rewrite these here, and you make the proper channel. For the next one, you multiply y by 1/2. We won't do it because I think you guys get the point. The second one, you guys get the point. Just multiply y by 1/2. So here's what I'm gonna do to save some time. I'm gonna copy and paste this. So Control C. Let's do the one in the lower left corner. Wait. Let me try this again. If I can copy and paste. Apparently not. Okay. I'm just gonna move it down then. Let me adjust this. Okay. Let me erase the other junk. Okay, here we go. You're gonna add 4 to each of these, right? So you're gonna add 4 to y. So you do 2, 2, 2, 1, 0, -1, 0. Sorry, we're adding 4. 3, 7, 7, 7, 7. So you're gonna have 2, 2, 2, 1. Come on. Connected. There you go. So see, I got elevated by 4 units. So you can transform anything. It doesn't have to be a general, like a square root or absolute value or x squared, x cubed. You can do something really strange, like this here, a piecewise function that is a mismatch of different lines and whatnot. But if you add a transformation to it, you do everything you've learned before. It's all universal. So we won't do the last one here, but this is just add 4 to x. So okay. In summary, just to talk about, and this is, by the way, if there's anything that you look at on Monday morning coming to campus before our test, look at this page. This is the best page to look at because it has the general stuff. A is a vertical shift, or sorry, A is a vertical stretch, or compression, or reflection. H is the horizontal shift. K is the vertical shift, or H and K could be like the vertex, right? And then you have all these other family of functions like lines, absolute value, parabolas, cubic, hyperbolas, square root, exponential. There you go. Okay, the homework's on the next page. There's some extra problems afterwards. We'll save that for later. Let me give you guys a copy of the test outline and the actual test reviews. It's really thick, don't be alarmed. Mine's so thick. Give you guys a little bit of inside details on this. Yeah, the bubble bed near giant. That'd be awesome.
Who gets the first seat? One with the tiebreaker. Watch that be impossible.
It can only make people design it.
It'd be impossible to play each other. Yeah.
What if they tie 16-0-1?
Then-
Straight to schedule.
Yeah, no, I think common opponents. So would that be the same too? Yeah, I guess so. No, I think we point differential. Or maybe it's just, no, maybe you're right. I think, and then if that's the same.
But it's not.
It probably won't, it could be, but I think the point differential. If everything's all tied, I think the last tiebreaker is a point. But we take like so much for that. Yeah. All right, so let's talk about the test, guys.
What's going to be on the test? Right. All right. So first off, this is a very generic, guys. Quiet, please. I just need a few minutes, and then you guys can start the homework quiz and then do homework. So you guys should have a lot of time to get stuff done. All right. So am I going to ask you to graph a quadratic function given standard form or vertex form? Absolutely. I'm totally going to have you graph the quadratic function. I'm not going to tell you what form it's in, but you're going to have to graph it, and those are sample problems, and that's extra practice right there. But you do good. Yes, I'm going to get to that in a minute. Yeah, I'll get those finer details in about 1 minute. Am I going to ask you to rewrite a quadratic function into vertex form by completing the square? Yes. So, guys, very important. Do not space out on this. Don't come to me during test. I'm like, I don't know how to do this because I'm telling you, it's on the test. You got to be able to complete the square. I want you to complete the square. We could practice that skill today after the homework quiz. But yes, I am going to ask you to complete the square. This one's a word problem. Remember the word problem we had with I think a person was jumping over there was a water hose or a trajectory, that kind of stuff. So yeah, there'll be a word problem like that. This one, just so you know, is gonna be a matching, where I'll give you a bunch of graphs and a bunch of equations, you gotta match them up. So there'll be a question like that. So this is definitely one question. This is definitely another question. This is definitely another question. This is definitely another question. You guys see how problems with there. So being very transparent here, totally. Actually, I don't think this will be on the test. There's a packet on circles that I just shared with you guys. The notes that we just did, the last 2 pages on circles. I don't think we're going to get to that. So let me get back to you on that. I'm not 100% sure, but I don't think we'll have a question on that. So don't worry about those last 2 items. I'll confirm by Wednesday with you guys. We may just cross those out. But the other, yes, are identify transformations. Yeah, write an equation. So this would be given a description. Let me write this better, sorry. Say, for example, I said, oh, here's an equation. It flips over the x-axis, and it's shifted 4 up, and it's shifted 3 right. Give me the equation. I could do something like that. And there's sample problems, total sample problems there. And the last one is more yeah, I'm stating transformations from a given equation or graph. So if I give you a graph and say, hey, what would be the equation of this? Or sorry, what would be the transformations are happening from the parent function? Sorry, that's what I meant to say. So it's just a reverse of 2f. So those are the types of questions we'll have. In terms of the format of the test, 60 minutes. So 1 hour with the standard time. So if you have time and a half or double time, you get 90 minutes or 2 hours. There'll be 2 parts. non-calc, and calc. And it'll be an even split. Between number of questions and point values. So they're gonna be weighted equally. So it'll be an even split. So I haven't, we haven't fully decided how many questions. Maybe there might be 6 questions, maybe there might be 8 questions. We haven't fully decided how many. If there's 8 questions, then won't have many parts to it. But it'll be an even split between the two. Just you know, it'll be an even split. Point values will be an even split. In terms of what would be non-calc or calc, this clearly would be non-calc. Why would I give you a calculator to graph something? Right. Makes sense. Actually, can I erase the other stuff right now? The blue and red. Can I erase it? Yeah. Okay. So this would probably be non-calc. This would probably be non-calc also because it probably involves some sort of matching bits. This is probably non-calc too. Whereas these other ones would be calculator. So that's what we're looking at. So that's a format of the test. The stuff that's after this. So if I go over here, it's not technically a practice test, so don't be alarmed. Because some of you guys might freak out, like, oh my God, is the test gonna be that big? No, I just told you it's not gonna be that big. But some of you guys might freak out. But so the rest of the packet is this. It's this practice test version. I went to the CPM online textbook. I created this practice test. And it's just a bunch of questions, 48 questions. No, you're not gonna have 48 questions on your test. Some are multiple choice, some are free response. But these are all good questions because these are things I'm going to ask you to do, right? And then the answer key is included. Here's the answer key. It's at the end. So it's all here. It's also on Schoology too. So if you happen to lose this packet, guess what? I put it all on Schoology as well. Or if you happen to like be somewhere, you left this at your house, maybe you're away for a sporting event, you're at a friend's house, or maybe you're out of town this weekend, I don't know. Don't worry. Just go back to the Unit 3 folder. As long as you have a device, you can access Schoology, test review, it's all there. So pretty much provide as much as I can. In terms of my availability on Sunday night, if you guys want to come in to Zoom and ask questions, I should be available. I'm not 100% sure when that will be. Let me get back to you on that. So that's just kind of up in the air right now. And I think that is it for now. And then we don't have office hours this week, unfortunately. But if you want to just ping me or come out during lunch, you know, I'll be in here. I'll be here this whole week. So anyway, let's do the homework quiz. After homework quiz, you can start the homework. Homework 19 is right here. It is due on Wednesday, you guys. It's the last homework for the units. So it's right here. Okay. And let's start the homework quiz. Here we go. The last question is a freebie. If you need help with the last question, just ask. Save this one. There's 3 questions, 2 more choice. Fun questions. The multiple choice question, you have to give a brief explanation in addition to your answer. You can't just give the answer, you have to give a brief explanation. Sorry. Testing 1, 2, 3, testing. It's working. Stop. Close.